welcome to another year of YouTube Maker's Secret Santa. You'll notice my microphone is actually on a wire today. That's the problem with rechargeable things. If they run out of battery, you've got to sit and wait for them to charge. Replaceable batteries, you can plonk them in and out. Anyway, rant over. So looking back at the YouTuber Maker's Secret Santa series, we've actually done a heck of a lot of years. I didn't really realise quite how many that have been done. Last year I managed to do a lowdown of all of them at the start, but it was getting a bit long. Props to everybody at Kids Invent Stuff for keeping this going, because it's quite amazing. That was, I don't know how many years it is. It's right here, I've lost count. This video is actually going to be a continuation of a project I've been working on with something called a Compton organ. If you've just clicked on this video and haven't got a fudging clue of what even a Compton organ is, well, let's just have a quick rundown. The Compton organ is a very, very early electronic organ design that was made by the Compton Pipe Organ Company. Compton Pipe Organs were a manufacturer that started in the early 1900s, making humongous bespoke church and theatre organs. A British organ manufacturing company that can be considered in a similar ilk to Wurlitzer and other companies like that. In the 1930s, they started to experiment with making electronically generated sounds for the organ. The first machine that they developed was the Electrone. It's quite a fantastic machine that's got two large discs that have all of the waveforms that you need. Then it all spins and you plonk 500 volts through the thing and it generates those tones out the other end. This Electrone was designed to be an expansion add-on to the pipe organs that they made. They never intended for it to be a completely standalone electronic setup. It uses the principle of electrostatics. This was actually to circumnavigate the patents that Hammond had. The Hammond organ was developed much like a guitar pickup, which uses the principle of electromagnetics. As a wheel with shaped teeth around the edge spin around, an electromagnetic pickup picks up the fluctuations in that spinning disc, which then sends out the fluctuations down the wire. In fact, here is a demonstration at the Italian Synth Museum, because the Italians actually made a version of this organ.
Wait, there we go. There we go.
Oh, that's the lights. And as you can see, if you put a guitar pickup straight up against the organ tone wheel, you can actually hear the organ tone wheel going through the guitar amplifier.
Oh!
Well, Compton, like I said, went down the electrostatic route, and it looks really cool because the actual waveforms are printed out on the disc. Amazingly enough, at the Italian Synth Museum, the same manufacturer that copied Hammond had also actually made a version of the electrostatic organ as well. As you can see, it's a bunch of gears. There's apparently tone wheels inside there. Didn't get to have a closer look. It looks really interesting anyway. Anyway, after this, Compton made fully standalone tone wheel electrostatic organs. And these actually had multiple tone wheels that were all being driven by the same belt.
Listen, try not to electrocute myself.
And through complicating switching relay circuitry, you were able to select different sounds and palettes coming from these tone wheels. I've done quite a few videos on this and other organs, and there is an organ playlist I've made below if you are remotely interested. In fact, one of these Compton tone wheel organs is sat behind us right now, but you didn't even realise. Let's just open it up. Oh, look at that. So there's actually one here. Yes, much like the other skeleton one that is in the playlist below that we're working on at the minute, well, this is another type, and the tone wheels are sitting right over here. There is one tone wheel per every note in the octave. And funnily enough, each of these tone wheels are actually exactly the same. The only way they differ is the size of the pulleys on them. The bigger or smaller they are means that the actual tone wheel rotates at a different speed, making the different notes. I haven't actually ran this one yet, but if I spin it, you can see it's spinning it all at once. In order to get anything from these tone wheels whilst they're spinning, you actually need to send about 500 volts DC into the back of them to get only a few millivolts of sound out the front of them. Compton tone wheel organs were still being made well into the mid-70s, which is when they started developing organs based on logic microchips. Funnily enough, the same month they were developing these newer logic chip based organs, they discovered that if you sent in a lower voltage, about 12 volts, but AC, you were able to make it work. This was only written in a paragraph on the history of Compton and making organs, but a couple of weeks ago I gave it a go, and lo and behold, it actually worked. Well, today we're going to continue on this low voltage version of the Compton organ to be able to make a Secret Santa gift for Becky Stern. This is one of the later types of tone wheels by Compton, you'll see right here, and you would have seen in the last video the inside of it, but I'll show you it again anyway. Let's have a look, see? This right here is the rotor, and that is the pickup. And this right here is the stator, and as you can see, it's got multiple sine wave waveforms spinning around the whole thingamajiggy. In the last video, you would have seen a setup where we got it to work with this low voltage being sent into the back of it, and then being received out the front via these outputs. The thing is, however, these tone wheels that I have in my hand are practically impossible to find, but a lot of these have by now probably ended up in the scrap pile. Most of them were in churches and theatres. However, in the 1950s, Compton also made a home organ that was based on these tone wheels. In fact, 12 of these tone wheels in a line, and you can still find a couple of these on eBay. However, they do weigh an absolute ton. So what I did was plonk both of these onto a scanner and basically design them as circuit boards. So today we're going to mess around and see if we can actually make our own Compton tone wheels. The first step in this process is improving the circuit that we made in the last video. This is the setup from the last video, and if you remember, there are multiple wires on the back connecting to the different waveforms on the stator. Well, the AC signal is going into these volume knobs before we go to the actual machine, so we can turn up and down those waveforms. Have a listen. So as you can tell with the low voltage setup, we're dealing with quite a bit of background noise, but hopefully we're going to get rid of some of that today when we make this machine for Becky Stern, which is basically going to be a drill synth. I think that's what we're going to try and make. The thing we're going to focus on is this. This is the signal generator that is sending 150 kilohertz, or pretty much actually 120 kilohertz, into the circuitry to be able to be received by the sound. We need to replace this with an electronic circuit, which will also make this louder, because currently I think this only sends out about 5 volts. We're going to be able to send about 24 volts into here. The circuit doesn't need to be complicated or fancy. In fact, we need to build this simple schematic right here, which is an operational amplifier, 3 resistors and a capacitor, making an oscillator, which is an alternating current frequency.
Here is me putting that circuit onto a breadboard, which is a temporary circuit making device for prototyping.
Here's that circuit right here. One of the resistors is now a variable resistor, so we can hone in the carrier frequency, but we can mess around later. But right now, as you can hear, we're pretty much where we were without this, so we can pull this off. Say toodly-doo to you. This is relevant for the people who watched the first video. You will remember that the receiver circuit that we made was based on just a kid's AM radio circuit. The issue was I couldn't get it working without the antenna coil for some reason. So I flicked over to the next page and used a little bit of the circuitry from here as well, including an extra diode, which comes from ground, and it means that we can recover more of the signals. At that point, I was able to remove this and also the tuning capacitor from the circuit. So now this circuit has 2 rectifying diodes and a low pass filter, and basically, and we've ended up with a much cleaner tone. Also, because this chip right here has 2 operational amplifiers, we're only using one to make the carrier oscillator. We can use the other operational amplifier to amplify the signal. This means we can listen to the carrier oscillator. That's this thing right here. It's so high pitched that you can't hear it. Not even your dogs can hear it. It's about 120 kilohertz. In fact, it might tell us on this fandangled machine. No idea how to use it. So that's traveling directly into the tone wheel. If we have a listen to the output of the tone wheel, you can see it's still there, but if we shake it, you can see it like vibrates a bit. You see when we spin it, it gets a little bit fuzzy. That is actually the amplitude modulation. So the carrier frequency, which is really high, is actually carrying the audible frequencies, which are very low, via the modulation of the amplitude. Once you rectify it, you end up getting something like this. It's a bit more noticeable. You can see when I'm moving it slowly, it's moving up and down. Then all we need to do is actually filter out the carrier frequency. Whoa. So the carrier frequency's pretty much disappeared. And now we're left with the actual oscillation. So let's have a listen to that. Yes! And it should come as no surprise that it actually sounds like an organ. This circuit, using a stronger carrier frequency, that slight adjustment on the receiver circuit, and also an amplification circuit, has resulted in a very, very clean sound. In fact, I'm actually really surprised and pleased at how little background noise there is, which is amazing. We've got a circuit that works. So the next step is to replace the rare and hard to find tone wheel with our own DIY one.
So for the first prototype, we're going to 3D print an enclosure, and then we're going to be able to sandwich the circuit boards between here. We're using these 6mm bearings, a 6mm shaft, and a 6mm flange. We're going to be able to push the bearings into the bottom and the top of the enclosure so the axle can sit between them. Then we're going to get the rotor and actually solder it with a big soldering iron onto the flange so it maintains electrical connection, because this is the output pickup. And then we're able to put them together with 0.2mm clearance and pop it together. And hey presto, bish bosh bash.
If it does anything.
Basically, my method of having a slip disc is really bad because it's very low level, and any kind of fluctuation or anything in the spinning ends up in a... I have a plan, but I'm not going to get it done in time for Becky Stearns. You'll see the second iteration at the end of this video, because funnily enough, this isn't the first time in Secret Santa I've actually done this where I've made a better version afterwards. But yeah, I'm changing the type of machine I'm making for Becky. It's going to now be called the Scratchy Drone of Doom.
Doing it till rather late last night. We've got the strip board right here. I drew out the schematic. I say schematic, it's more like a schematic drawing, idiomatic, let's say. So there's the tone wheel. There is the carrier oscillator. Here is the receiver circuit that's got the rectifiers, and then that goes into a amplifier and then out the output. So we're going to plonk this, and a power supply into this box. Very interesting indeed.
Which is very simple. We just drill some holes to be able to plonk it all onto the casing. So tone wheel at the top and then circuit board at the bottom. Lovely jubbly.
It's not working. I'm really running out of time on this, so I'm going to have to put one of these in for Becky Stern. I've got a handful of these still, so that's all right. So I'm going to plop this in.
After adding a fair few doodles to try and avert people's eyes from it being a pretty rubbish machine, we're going to plonk it together and add a really big flywheel onto the front of it, which will give it momentum to keep on spinning like a boo. That's the plan of it, and it's going to also hypnotise Becky Stern at the same time. Win-win!
So here is the one we're going to be sending to Becky Stern. As you can see, it spins around for a long time. It's pretty nice. Oh, I've got a mustache. Oh no, I'm covered in crap. I was just working on the latest Look Mum No Engine video where I'm putting hydraulic brakes on the Aussie 7, the Australian Austin 7. Video is probably up by now. Links below. But anyway, let's see what this sounds like. I mean, it's pretty simple. It's just going to go boo. But you can also like scratch with it. That's pretty cool. Anyway, we best get it posted. And look what has just come through the door. It's a big old box. It says it's actually from Austin Bradley, who is a maker YouTuber from America. So this has made it halfway across the world. And by the looks of it, he makes some pretty wacky 3D printed items. So gosh knows what's going on in here. Oh. 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 Oh, here we go. Okay. Also, you'll notice that there is some home office tape on the bottom of it. So I'm assuming that it's actually been opened. Home office border force. So yeah, it might have been opened already, but I have a funny feeling I know what this is, but
What the fudge? Okay, we got some waffles. Oh my God! Dear Mr. No Computer, Merry Christmas from your Secret Santa. Big fan of your work, oh thank you, both visually and musically. Hoping you get at least an hour of joy out of this gift. I spent a ridiculous amount of time thinking of what to make you, but I eventually settled on our common interest, Furbies. Oh, he's got the font and everything. Oh my gosh. Oh, my hands are minging. Oh, I've been doing other things today, I'm sorry. Wow. Look at the instructions. I thought that was real Furby instructions. This does not hurt the creature, probably. Ooh, look. There's some funky stuff inside of my Furby. What in God's name is this? For emergency maintenance, the entire lower half can be unscrewed. Yeah, this shouldn't have to happen. Okay, so I fear I may have ruined the mystique because now I can't turn it off. But the cool thing is, as I've noticed, it's a really fancy kind of pad design where you pop this on and then you turn it up. It actually carries it through. It propagates the sound. I really want to take it apart, but I know I shouldn't because that's really interesting. And then that carries through, and then you can pop. Wow. So it's a Furby lightsaber, obviously. It is absolutely amazing. I'm amazed by it. It's yeah, it's not even a real Furby. It's actually a 3D printed Furby, which is quite amazing. There's a button on the back. Where's the button? How amazing is that? Oh, this is so sick. Oh shit, I broke it. I literally broke it. Oh no, I got too dizzy. Oh. Okay, I've got to glue it back together. I'm so sorry, Austin. Oh, for God's sake, I'm running out of time as well. Okay, follow back for this. I've got to fix it now. I've got to get this video uploaded in an hour, so I'll fix this in a moment. I'm sorry, Austin. I will make sure it is rectified. I don't believe I broke it. I have committed a sincere crime. Yeah, it's like it's snapped on the gold thingamajiggy. Oh no, but it works. I've just got to, none of the wires have come off. I've just got to stick it all back together. Oh, what an idiot. Crying at the pain.
I'm sorry, Ashley. I definitely will get that fixed. It's very silly of me. This is iteration 2 that I got done just yesterday, and it's got a rear back plate now. That is the pickup, and that is wirelessly connected. So that's connected to the output, and then we've got the rotor, 0.2 millimeters clearance between those two, and then there's another 0.2 millimeters clearance between that and the other plate for the input. And yeah, there's a version 3 coming, and you'll see more on that as it comes. I'll have a video in a couple of weeks of this, but it's already way better. There's a lot of potential of using this to make an actual functional instrument. I've already done a video on this on Patreon if you're interested. If not, check back in a couple of weeks. Anyway, if you made it to the end of this very nerdy video about electronics, then very well done. Go and check out the rest of the Secret Santa videos. The playlist is below. Merry Christmas!